Dear friends, we are going to see the similarity of triangles. Look at these figures. Two circles, two squares. Different in size, but then they are similar in shape. And therefore we say all the circles have the same shape, certainly. All the squares have the same shape. Look at the other triangles. Look at these three. Suddenly their shape is different. They are triangles but with different shape. Look at these two quadrangles. Four-lined figures, but then both are of a different shape. And therefore we say all the circles have the same shape, all the squares have the same shape. Not all the triangles are similar. So same shape finally means what? Same shape. Similar means same shape. So we say all the triangles are similar, all the circles are similar, all the squares are similar. However, not all triangles are similar, different. Not all the quadrilaterals are similar. What does therefore similar mean? Same shape but not same size. In that connection, we also want to highlight congruent. Same shape and same size, because these two words are very often used in geometry, similar and congruent. Just remember the difference between the two. We now go to the criteria for the similarity of triangles, and we have three criteria which form also theorem 6.3, 6.4 and 6.5. The first criteria, triple A, or the three angles of one triangle are equal to the three angles of the other triangle. It can also be two angles, because suddenly the third angle will be automatically similar. Look at this, one right angle here, one right angle, and this angle equals this angle, and this angle equals this angle. All the three angles are equal from one triangle to the other, triple A. We now go to the second one is triple S. That means all three sides of one triangle are proportionate to the sides of the other triangle. What's the meaning? In the same ratio, not same size, same length, but same ratio. And that is 6.4, theorem 6.4, triple S. And we have the third criteria, SAS, two sides and the inclusive angle. Theorem 6.5, two sides, AB upon AQ, BC upon QR. Included angle, this is 70, this is 70, included angle. And therefore, two sides and one angle, therefore the triangles are similar. In regard to exercise 6.3, the questions certainly are based on what we have learned about the criteria for the similarity of triangles, and therefore we are just revising. If the three angles of one triangle are equal to the three angles of the other triangle, then the triangles are similar. If two angles, then also they are similar. If the sides of one triangle are proportionate to the sides of the other triangle, then they are similar. So we are just revising once again, because the exercises are based on these three theorems. They will give you either similarity or equality or whatever it is. Make use of what is given in order to find out what you are asked to do. And then we have the last one. If two sides of one triangle are proportionate to the two sides of the other, then their inclusive angles are equal, then they are similar. Please remember, it would be advisable that you study by heart theorem 6.3, 6.4 and 6.5. Question number 6. We have given two triangles where two angles are same, 80, 80, and here 70, here 30. Certainly they are not equal. But we find out, are the three angles equal to each other? The three angles of one triangle to the three angles of the other. Look at what's happening. 1, 2, 3 angles is equal to 180. We know that. And now we give the value 70, 80, 70, 80, then 180, and you do it 150, 180. Therefore, F is equal to 180 minus 150 is equal to 30. So this angle will be 30. So 80, 70, 30, 80, 30. And let's look at this second one. 1, 2, 3, 180 and P is not there. Therefore P 80, 30, 180 and 110, 180. P therefore is equal to 180 minus 170. So this angle is 70. 80, 70, 30, 80, 70, 30. All the three angles of one are equal to the three angles of the other. Triple A, therefore the triangles are equal in all respects. So friends, we are now tackling question number 11. The same procedure. Read the question, understand the question and accordingly draw the figure. This is a little tricky question and you have to draw the figure very clearly, but follow the instructions. And therefore, what are we given? Triangle ABC. AB is equal to BC. We are given there AB is equal to BC, which means the triangle is isosceles. We will understand the consequence of that after this. And next one, AD is perpendicular to BC and EF is perpendicular to AC. Perpendicular means 90 degrees angle. To be proved, triangle ABD is similar to triangle EFC. ABD is similar to EFC. And this is right angle, this is right angle. These two sides are equal. That's a marking, so you know immediately what is equal. Now we prove. Since ABC is an isosceles triangle, the angle, base angles, ABC is equal to ACD. ABC is equal to ACD. And from here we say ABC is same as ABD. And therefore we say ABC, ABD, ACD, ACD. So from here, this is very clear because the same angle with the different names. Now, in the triangles ABD, ECF, ABD and ECF, ECF or EFC, you can do whatever you want. Angle ABD is equal to ECF. From here, what we have already given, because these two angles are equal, it's given. Second, ADB angle EF is equal to EFC. ADB, EFC, given again, they are right angles, it's given the question. And therefore, two angles are equal, immediately it's clear, the triangle ABD is similar to triangle ECF. If two angles are equal, or three angles or two angles, and therefore we have theorem 6.3, which is triple angle, but enough two angles, the triangles are similar in all respects. We have proved. It's quite simple, I should say. Friends, we are now going to tackle question number 13 of exercise 6.3. I would like to remind you that you should understand the question clearly. In order to help you to do that, I have given here what is given in the question. What are we given? Certainly not in the same order, but we are given that ABC is a triangle. AD is drawn in such a way that angle BAC is equal to ADC. You find the marking to show that they are equal. We are given that. And then what are we supposed to prove? To be proved is equal to CA squared. That means CA into CA is equal to CB into CD. To clarify it, into CD. The proof. In triangles ABC, so here we have got ABC and ADC. Two triangles. BAC is equal to ADC. We are given. We are making use of what is given. And the next one, ACB is equal to ACD. It's common. This angle is common to both the triangles. And therefore, immediately we conclude triangle ABC is similar to triangle ADC according to theorem 6.3. If two angles of one triangle are equal to the two angles of the other, both the triangles are similar. similar. And therefore, since they are similar, we can conclude AC upon DC. AC upon DC is equal to CB upon AC. And then what do? We just cross multiply. That is AC into AC or AC into AC. And then here DC into CB. These cross multiply. And we have this. AC into AC is equal to CB into CD. Now AC is same as AC squared or CS squared. Because we are asked, we are given CS squared, and therefore we write here AC same as CS squared is equal to CB into CD. And that we are what we are asked to prove, and we have proved it. Quite a simple question and a simple answer, we can say. But try to understand the question, because that is what is important. From what is given, we make use of what is given, and accordingly we prove, making use of the theorems that we are learning now, similarities of triangles. We have now question number 16 of the same exercise, 6.3. Read through the question. It's a little difficult, but not so difficult. What we have to understand are the meanings of the words. Median. It's given the medians of BC and QR. What's a median? From the vertex to the middle point of the baseline, that's a median, which means these are equal. They are middle point. Okay. So what are we given? Triangle ABC is similar to triangle PQR. They are similar in all respects. Okay, there it is given. And then AD is the median on BC, AD median on BC, and PM median on QR given again. Okay. To be proved, AB upon PQ, AB upon PQ, AB upon PQ is equal to AD upon PM, AD upon PM of the two triangles. Proof. From what is given, we begin. Since they are similar, the sides are proportionate. Triangle similar, sides are proportionate, and that is the reverse of theorem 6.4 that we have already given. So therefore we say AB upon PQ. AB upon PQ is equal to AC upon PR is equal to BC upon QR. But however, we know that BD is half of this BC and QM is half of QR. So divide by 2, divide by 2. And therefore we say BD upon QM, BC upon QR is same as BD upon QM half exactly. That is the second point that we have proved. And therefore, in the triangles ABD and PQM, now you take ABD and PQM. Immediately we find that AB upon PQ is equal to BD upon QM from 1 and 2. From 1 and 2 we see here, and then AB, BD, and therefore we have that. And then therefore the triangles are similar. Triangles are similar in all respects. And since the triangles are similar in all respects, we say AB upon PQ is equal to AD upon PM. AB upon PQ is equal to AD upon PM, what we are given to prove.